Hello. In this video, we're going to be going over trace tables for assembly language. Now, in this paper, we are given a question based on this topic, and in an overview, it is a very straightforward question because we are given a big table of information. One, for all the opcodes that are being used in this question, all the operands, and what they are either a number or an address, and the explanation for what each of these opcodes do. We are also given the set of instructions that we have to go through, as well as, in this question, some ASCII values. Now we read that the table shows part of an instruction set for a processor. The processor has one general purpose register, the accumulator, and an index register. And the current contents of the main memory and selected values from the ASCII table, ASCII character set are these two tables here. Now, we are given a trace table, and it says complete the trace table for the program currently in main memory when the following characters are input, A and D. And we know that A and D correspond to an ASCII value that we have to start with. So let's start this question by always reading the first address and instruction. It is 70, address 70, and instruction in. So we go to our trace table here and we find the column in instruction address. In that instruction address, we have to put our address that we start with, which is 70. And we read the instruction, which is in right here. Key in a character and store its ASCII value in ACC. So key in a character and store its ASCII value in ACC. So our character is A, its ASCII value is 65. So in the ACC, we have to put 65. Next address, we're going to put a line through so we don't get confused. Next address, 71. Let's go down here, 71, in our instruction address. And our instruction is CMP 100. CMP, compare the contents right here. Compare the contents of ACC with the contents of address. So it's a compare instruction. So we have to compare the contents in address 100 with 65. So in contents 100, our value is 68. Now we know that 65 does not equal 68, so it is false. Now there's nothing being said for us to input anything into the ACC, so we have to leave it blank. So we cut through here on top, and we go to the next instruction address, which is 72. It says JPE 80. So we find JPE right here. Following our compare instruction, jump to address if the compare was true. Now we know that 65 does not equal 68, so it's false. So hence nothing will occur. So we must do nothing to the ACC, and we go to the next address, which is 73. 73 says CMP 101. CMP, compare the contents of ACC with contents of address. So it wants us to compare the contents in the address of 101 with 65, which is in the ACC. And the contents of 101 is 65. Now we know that 65 equals 65, which means that it is true. So we're going to go here, and we're going to go to address 74. Now, we know that it is true, and we know that in a JPE jump, we could say, we know that it's true, so we know we have to go to the address which is given. So we cannot put 74 because we are going to a new address. So it says JPE 76 because now we know as it is true, we have to jump to the address of 76 here. So we're going to go cut this, and we're going to put our address now 76. And it says LDD 102. So we go back to our table and we find LDD, which is right here. It says direct addressing, load the contents of the location at the given address to ACC. So load the contents of the location 102 into ACC now. We look at these small table of values here. 102 has the value 100. So in our ACC, we're going to put 100. 100. We go to our next instruction. We cut this. Now, 75, we didn't do address of 75. Now, that's because we cannot go back and complete an instruction in main memory. We cannot go back an address. So we have to just skip that and go right after 76, which is now 77, address 77. Let's put that there. Now 77 says increment. So INC, which is right here, add 1, so increment. Sorry about that. Add 1 to the contents of the register ACC or IX. So IX is not given in this table, so we know that we have to use the ACC. So add 1 to the contents of the ACC, which is 100, so 100 plus 1 is 101. So that is our new value in the ACC. Let's cut a line through that, and let's go to next address, 78. So I'm going to put 78 down here, and we're going to read the instruction here. STO 102. So we find STO, which is right here. Store the contents of ACC at given address. So our given address is 102. And we have to store the contents of 101 into 102. So our memory address we find is 102 because we have to store the value of 101 and 102. So we go here and we put 101 in memory address 102. Put a line through that because we've completed that. Now we go to next address, 79. Jump to 70, address 70 now. So we jump to address 70. So we did that. We completed that address. So we still put 79 there. And so we jump to address 70. 70 is in. It says key in a character and stores ASCII value in ACC. So we did A. So now we have the key in the character D and its ASCII value. And its ASCII value is 68 here. So we're going to put 68 in the ACC. We're going to put a line through that. Next address, 71. And I know that as we put a line through these other ones, we have to now realize that we are now going back to address 70. And I did say that we cannot go back an instruction because we cannot go back an instruction physically, but there are certain instructions that allow us to go back to either the start and to put new values in. So now 60, address 70, and in the ACC we store 68. Now, in an exam, you probably would have written with pen and cannot rub out the pen. But in this case, I'm just going to rub it out. I'm just going to rub out a few values here, just in case. So now we have 68 in the ACC, and we go to the next address, 71, right here. It says compare the address in 100, value of in the address 100, which is 68. Oh, 68 equals 68, so it's true. Okay, so we cut that value. 72, address 72. Let's go. And it says jump to address 80. So we completed 72. Now we go to address 80 because it's true. So we're going to put 80 here because that's the new address we are doing. And in address 80, it says LDD 102. Okay, so we didn't have to use address 73 and 74, maybe, I don't know. Sorry, 73, we didn't have to use 73. But now we're back at 80. Now 80 says LDD 102. So we find LDD right here. Direct addressing, load the contents of the location at the given address to ACC. So LDD 102. 102 has the value 100. So LDD has the value 100. And we're going to put the load the contents of the location at the given address. So 102 has 100. So we're going to put 100 in here. 102. Now our new value for 102 is 101. So we're going to put 101 now into ACC because as we know here that the new value stored in address 102 is 101, not 100. Sorry, I got a bit confused there because I was looking at that table. So I should have looked at this table. So during these questions, simple mistakes can occur, like the one I've just made there. So always be careful and do not do what I do. So now we cut 80 and we go to the next address, 81. Store that in the instruction address. And it says DEC, decrement the value of ACC, which is, and we can find that here. Subtract 1 from the contents of register ACC or IX. So in this case, it's ACC, which is 101. And we're going to subtract 1. So now the new value in the ACC is 100. Put a line through that. Address 82. Let's put 82 here. Store 102. So the address of 102. Let's find store, just in case. Store the contents of ACC at the given address. So store the contents of the value in ACC to the given address, which is 102. So we have to store 100 in memory address 102. So we're going to put 100 here. So now that is the new value that is stored in memory address 102. Let's put a line down here. And so for our last instruction, it is in the address 83. And it says jump to address 70. And yeah, that is it. We leave it blank because we are not given any further characters to key in. And that is it. Now in this question, we are also given simple binary and some logic gates that we have to operate on. But in this video, we will be only covering trace tables for instruction sets. And that is it. Thank you. Now, when answering this question, just remember that it is very straightforward and the answers are given in the first page. All you have to do is just input the values. You are given the table of information that gives us the explanation for what they do, and you're given the set of instructions that you have to work through. And that is it. Thank you.